Hey guys, welcome back. This is going to be part three of our video number three in our series of 7.3 videos, where we're learning about elimination. And we just have one more problem I want to cover just to make sure we have a solid grasp on elimination. If you haven't watched the previous two 7.3 videos, part one and part two, please do that before you watch this one. This one probably won't make a ton of sense if you haven't watched those. So let's solve this problem. So I look at this system of equations and I'm trying to find the solution to it. I know substitution isn't a great idea because no variable is lacking a coefficient. There isn't an easy variable to get by itself. So I turn to elimination and I go, can I add or subtract the two equations, the left side to the left side, the right side to the right side, and cancel a variable off the bat? Get rid of a variable so that I have a single variable equation. Answer, no, I can't. 4 plus 7 gives me 11. 2 plus -3 gives me -1. In that case, neither variable cancels. 4 minus 7 would give me -3x. 2 minus -3 would give me 5y. Again, neither of those variables are canceling. So what am I going to do here? What am I going to do? Well, we learned in part 2 of 7.3 that we could multiply an equation by a number, and as long as we multiply the whole thing, it didn't fundamentally change the line. And we did this to line up our coefficients so that when we added or subtracted the equations, they would cancel in our elimination process. But even if I would think about doing that here, there is no nice, neat integer that I can multiply the top equation by that will then line up the coefficients to cancel one of the variables in the bottom. What do I mean? Well, 4, there's no nice number to multiply by 4 that I get 7 or -7. There's no nice, neat number that I can multiply by 2 to cancel then with -3. There's nothing nice and neat about this problem. It's a fairly difficult one. So what do we do in situations like this where elimination seems to be our best method, but none of our previously learned methods have worked so far? Well, we just kind of have to brute force the problem. What we're going to do is not multiply one, but both of the equations by some number to line up one of the coefficients or one of the sets of coefficients for one of the variables. So we learned in part 2 of 7.3 that we could multiply equations by a number, and as long as we multiplied the whole thing, it didn't fundamentally change the equation. We did this to one of our equations so that we could line up our coefficients and cancel one of our variables. But since even that won't work here, we're going to have to multiply both equations. Now, we got to figure out which variable we want to get rid of first. And I think off the cuff, you would agree with me that we probably want to get rid of y. Could we get rid of x by lining up the coefficients in front of the x's? We could, but that's going to take working with bigger numbers, right? We would have to get both 7x and 4x. We'd have to multiply by numbers to get them both to be 28x. Okay, that would be the factor we would go with. Whereas 2 and 3, we can get them to have matching coefficients of 6, and our numbers are going to be a lot nicer. So what we're going to do is very similar to the part 2 instructional video of 7.3, but we have to multiply both equations to line up our coefficients. So what I'm going to do is I'm going to try and get a matching coefficient number of 6 in front of the y's. They'll have opposite signs because 2 is positive and 3 is negative here. But I'm going to try and get that physical number to be 6. So I'm going to multiply the top equation by 3 and the bottom equation by 2. Why am I doing that? Because then those coefficients will line up. So I do that and I get 12x plus 6y equals 42, making sure I multiply everything through in my top equation. Then I multiply my entire bottom equation by 2. And again, you could have also multiplied by -3 or -2. Again, the sign isn't really important here for the coefficient in front of the y. We just want the number to line up. So I go ahead and do this. And again, I haven't fundamentally changed these equations. If you would use a graphing software like Desmos, you would graph the two lines in blue and then graph the two lines in black. Your two lines in black would fall on top of their respective blue lines. They're the exact same line. So what we're going to do now that we multiplied both equations, now we have coefficients lined up that we can eliminate them. Specifically, we'll eliminate the y's. The question is, do we do this by addition or subtraction? We are going to do addition. And again, the answer to that question is always, how do you get a variable to have a coefficient of 0? If I would subtract here, 6 minus negative 6 would be positive 12. But by adding, I get rid of the y variable and get a single variable equation. So I add these together and I get 26x, 6y plus negative 6y is 0, and I get 42 plus negative 16, which is 26. Divide both sides by 26, and I find that x equals 1. From here, plug your x back into one of your equations. Could plug it into the top or the bottom. Wouldn't plug it into either of the black ones, though we could, because they are types of our original equation. They just have bigger numbers. But I don't want to do that because they have bigger numbers. Work with the simplest one. I have 4 times 1 plus 2y equals 14, which simplifies down to 4 plus 2y equals 14. I minus the 4 from both sides, and I get 2y equals 10. Divide both sides by 2, and I get y equals 5. And again, when we interpret that, I'll write it in red. This means that these two lines, the two original equations, which both produce lines, will intersect at 1, 5. 1, 5 is the x and y respective coordinates that when plugged into the original equations will not make one, but both equations true. And really here, I hope you walk away seeing nothing new. I hope you see that the whole elimination process is pretty much the same. We just had the added step of having to multiply not one, but both our equations by a number to get a variable or to get a coefficients to line up so that we could cancel the variable. Guys, this will conclude not only this video, but 7.3 in general, where we covered the topic of elimination. Hopefully, as we've gone on, it's started to make more sense, but if it doesn't, as always, let me know how I can help. Thanks.